to present ICLR paper 2025 published. That paper name is Training Free Diffusion Model Aligned with the Sampling Demo. I will explain the motivation, algorithm, result, and possible improvement from my own understanding. Okay. So the problem addressed in this paper is that diffusion model generates the high quality images but not always align with the user intention. The training based alignment is very costly and also it also many rewards like VLM score, human feedback and non-differential self are also applicable for this. Hence, the author aims for the training free inference time approach. So the key idea overview. Okay, so this the core idea is very simple and powerful. Instead of modifying the entire model, modify just a sampling process. A specific timestamp, the model generate the multiple possible continuations. So each continuation is get score and best one is selected by the daemon. This align output without retraining. Here, author used the Maxwell-Demon analogy to explain the intuition behind this method. In physics, Maxwell-Demon selectively allow only the fast particle to uh, pass, creating an ordered state from the randomness. Okay. So similarly, sampling demos selectively choose the better image branches from the random noise. And what I understood from this analogy, like that, it helps us to visualize the alignment as selective filtering rather than the optimization. The daemon act like a gatekeeper during the sampling and guiding the diffusion process towards the high quality or more aligned images. Now the most important part of this research paper is that we will going to discuss about the algorithm. Okay, in this slide, the core algorithm is given step by step. We start with the usual Gaussian noise that every diffusion model use. As per the timestamp, the model generates the k alternative continuations. Basically the different possible features. Each continuation is partially diagnosed and turned into the rough images, which is then evaluated using the reward function, which we'll going to discuss in the next slide. The branches that score is highest in the reward that is selected, and other sampling continues from that state. The key technical details is that after selecting a branch, a noise is renormalized so that diffusion assumption remain valid. So this approach convert the alignment into smart search across the noise spaces. Reward function. The strength of this approach is that it works without any reward resource. The traditional training based method needs differentiable rewards because gradient must flow black. There is oh sorry, the gradient must flow backward. But here no gradient is required. So the reward can come from the clip, aesthetic model, and vision language model API, or or even human clicking one of the branches. Okay, the flexibility is very important because the real world alignment is often rely on the human judgment or external scoring model. So this method essentially says as long as you can score it, you can align it. Now we will come to the experimental setup. So in experimental setup, it author takes the multiple approach. Here text to image generation, compare baseline sampling with the sampling demons, reward include with the aesthetic score with the CLIP clip, or human evaluation conducts. These are the approaches author has followed during his experimenting. In the experiment, author has compared normal sampling with the daemon-based sampling across multiple prompts and evaluation types. Daemon-based sampling consistently improve the aesthetic score and prompt accuracy, Human evaluators are also prefer the demand generated based image most of the times. The strong point here is that this improvement come without the any retraining. So the base model remain untouched. This shows that alignment can be significantly improved through the sampling alone. So from the analysis, it is a clear advantage that sampling demand provide alignment that is cheaper, modular, and compatible with existing model. However, the method is not perfect. It increases the inference cost because multiple branches are evaluated at once. The other limitations is always picking up the highest scoring branch that can reduce the diversity. But since the model is may rapidly choose a similar level of high reward patterns, this bring up the interesting design challenge. How interesting design challenge such as how to balance the alignment with the creative diversity. So what I understood from this interpretation. Okay. So from this paper, what I understood, the key strength is shifting alignment from training to sampling. That is the main approach. What I understood from this research paper. I feel this is the intuitive and easy to apply and ideal for the small research environment. Now we will come towards the limitation and possible enhancement. For potential enhancement, what we can see, reducing the compute, maintaining the diversity, extending to other modularities, sorry, pardon me, and improving the human UI and combining the multiple rewards. These are the limitations and possible outcomes for enhancement. What I could see. Now we are at a conclusion. In a conclusion, what I can say, sampling daemon is elegant idea. Instead of changing the model, we can change the sampling process. It is simple, effective, and open a new path for the inference time alignment. To conclude this research paper review, what I would like to say, sampling demand present a simple yet powerful idea. Instead of retaining the diffusion model for alignment, we guide them during the sampling by branching, scoring, and selecting the best continuation. This turn alignment into the lightweight and inference time decision process that make even for the human feedback and black box rewards. The result shows the clear improvement in the aesthetic quality and the prompt accuracy. In this method remains entirely the training free. What I personally appreciate is that how intuitive and practical this approach is. It is open it is open the door for many future enhancements such as adaptive branching, multi reward balancing, and extending this idea into text, video, and multi-model generations. Thank you. Let me know that you have any questions or doubts. Thank you.